Today we're going to learn about multiplying and dividing rational expressions. First, let's simplify a rational expression. Keep in mind, these are all expressions because there are no equal signs. These are not equations. Simplify the following and state excluded values. Excluded values are any value that has ever made the denominator equal to 0. Even if that value reduces out and is not part of the denominator in the final answer, it is still an excluded value because at one point it made the denominator equal to 0. How do we deal with rational expressions? Now remember, you cannot reduce any common terms unless you have a product in the numerator and the denominator. You can only reduce values that are factored. So we're going to begin by factoring. The first thing I notice is the numerator is not in standard form. So I'm going to rewrite it in standard form, and I'll explain why later. Now that the numerator is in standard form, I have a negative in front of my x squared. Because it's much more complicated to factor with a negative in front of your x squared term, we want to factor out that negative. Let's continue factoring. X squared minus 49 is the difference of perfect squares. And the denominator has a GCF of 3x squared. Once the denominator is factored, I can see what my excluded values should be. Anything that makes this denominator equal to 0. Solve for x, and you get x equals 0. If you plugged in x equals 0, then your denominator would be 0. Solve for x again in the other factor, and you get x equals 7 would make the denominator equal to 0. So my excluded values are 0 and 7. X cannot be 0 or 7. Once your rational expression is fully factored, you can reduce common factors. X minus 7 divided by x minus 7 is 1. This negative 1 in the front makes the entire fraction negative. Once you write it this way, you no longer need the parentheses. Or you could have distributed the negative 1 back in. So this rational expression simplifies to be negative x plus 7 over 3x squared, where x cannot equal 0 or 7. For part B, begin by factoring. Before we reduce, let's find our excluded values. Anything that makes the denominator equal to 0. That would be 6 or 8. Now reduce. B minus 6 divided by B minus 6 is 1. And you're left with the expression B minus 1 over B minus 8, where B cannot equal 6 or 8. For number 2, find each product or quotient and state the excluded values. Wow, look at part A. The numerators and denominators are all already products, so you do not have to factor, you just need to reduce. 8 times 7 is 56, x cubed times x to the 4 is x to the 7, and y times y cubed is y to the 4th. In the denominator, we have 8x y cubed. Now let's look at those excluded values. What can't be 0? Well, x cannot equal 0 and y can't equal 0 because both of those would make your denominator equal to 0. Now let's reduce. In order to reduce it, let's divide. That makes our answer 7x to the 6 times y with excluded values of 0 for x and y. For part B, begin by factoring. Now that your denominators are factored, find your excluded values. X cannot equal negative 5, it can't equal positive 1, and it can't equal 0. Let's reduce. 3x divided by 3x is 1. X plus 5 divided by x plus 5 is 1. You may think you're done reducing here, but 1 minus x divided by x minus 1 can be simplified further. What we can do is factor out a negative, which will change the signs of 1 and negative x. If it helps, you could rewrite that factor in standard form. Now we can reduce x minus 1 divided by x minus 1. At this point, we don't need the negative factored out anymore, so we'll distribute it back in, making our answer negative x plus 4, excluding negative 5, 0, and 1. For parts C and D, let's evaluate the quotients. Remember that when you divide fractions, you need to keep the first fraction the same, change the division symbol to multiplication, and flip the fraction after the division symbol. Your teacher may have called it keep, change, flip. Let's do that for part C.
But
But what would I consider my excluded values? Because in the original problem, x squared minus 11x plus 30 was the denominator. But now, x squared minus 6x is the denominator of the second fraction. So what are my excluded values? Let's consider dividing fractions like this. We want to divide a over b by c over d. We could also write that as a complex fraction. In this complex fraction, which variable is the denominator? Well, b is the denominator of a over b, d is the denominator for c over d, and c over d is the denominator for a over b. Guess what that means? B, C, and D are all part of denominators. So B cannot equal 0, C cannot equal 0, and D cannot equal 0. So when we're dividing fractions, we get excluded values from whatever makes any of our denominators equal to 0. The top denominator, the bottom denominator, and the overall denominator. So let's keep that in mind for when we finish factoring this. Now let's figure out those excluded values. First of all, the excluded values would be anything that makes the first denominator equal to 0. Another excluded value would be whatever makes our second denominator equal to 0. And our final excluded values would be whatever makes the original denominator, which is now our numerator, equal to 0. Oh, and that would just be 5 and 6, which we already have in our excluded values. Let's reduce. Wow, this entire thing reduced to be 7 over 2. Isn't that so satisfying? Don't forget, x cannot be 0, 5, or 6. Let's try part D using the same method. Feel free to pause and try it on your own, and then press play to check. Our original denominator of the second fraction of 1 does not have a variable, so nothing would make that equal to 0. But our first denominator and our new denominator will give us 2 more excluded values. So once you've written your excluded values, you're done. But guess what? If you leave it like this, you will absolutely get it counted wrong. Because x cannot equal 0. That's literally what it cannot equal, which is why this heading is really important to remember when you're solving for these. We make them equal to 0 to find what would make them equal to 0, right? So in your final answer, you absolutely have to show the excluded values as x cannot be 0 and x cannot be negative 5/3. That's the definition of an excluded value. So just a reminder, excluded values are what x can't be. And that is simplifying, multiplying, and dividing rational expressions.